All right, let's get right into it. We all live in a world that runs on Wi-Fi, right? But what happens when you need to connect something that's way, way beyond the reach of your router? That's the real challenge, and it's exactly what we're going to break down today.
I mean, really think about that for a second. A sensor out in a huge field, a water meter buried deep in a basement, a truck that's driving across the country. None of them can just hop on your Wi-Fi, and you're definitely not going to run a cable out to them. This very problem is why a whole class of technology even exists.
And that solution? It has a name. Wireless Wide Area Network, or WWAN for short. You can think of it as this big umbrella term for all the tech that gives our remote devices a voice, no matter where they are.
So, here's the game plan for this explainer. We're going to start with that core anywhere connection problem. Then we'll introduce the two major families of connectivity. After that, we'll meet the key players on each team, figure out the rules for how to choose the right one, see them in action with some real-world examples, and finally, we'll take a quick look at what the future holds. Sound good? Let's jump in.
Okay, the first thing you need to understand about the world of WWAN is that it's not some big, confusing mess of technologies. It's actually much simpler. It's really split into two very different families, two distinct approaches to solving that same problem of remote connectivity.
And this, right here, is the perfect analogy. You wouldn't use a Formula One race car to haul a bunch of cargo across the country, right? And you definitely wouldn't enter a giant freight truck in a Grand Prix. It's all about picking the absolute right tool for the job you need to do.
So on one side, you've got the high-speed family. Think 4G and 5G. These are the Ferraris. They're built for high throughput, that means sending tons of data, and fast. And they have low latency, which means almost zero delay. Perfect for things like streaming video or controlling robots in real time. Then, on the other side, you have the low-power family, also known as LPWAN. These are the marathon runners. They're designed to send just tiny bits of data over massive distances while barely sipping any power. We're talking set-it-and-forget-it devices that can last for years on a single battery.
Okay, so now that we know the two families, let's meet the star players on each team. It's time to check out the lineup.
On the high-speed team, we've got some names you'll definitely recognize. First, there's 4G/LTE. It's the dependable workhorse that powers our smartphones every single day. Great coverage, super reliable. And then you have 5G. This is the next-gen powerhouse. It's not just about being faster, its incredibly low lag time is what enables totally new things, like private networks for industrial automation.
Now, over on the low-power team, the names might be a little less familiar, but trust me, they are just as important. You've got LoRaWAN, which is the long-range champion. It's perfect for blanketing huge areas, like a farm or an entire city with thousands of low-cost sensors. Then you have NB-IoT and LTE-M. You can think of these as the cellular industry's answer to the Internet of Things, bringing that carrier-grade reliability to the low-power world.
So, we've met the players on both sides. Now for the most important part. How in the world do you decide which one to use? This is where we need to get strategic, and it all boils down to understanding a few key trade-offs.
First up is range. This is a big one. Technologies like LoRaWAN are incredible here. They can send signals for kilometers from just a single gateway. Cellular, on the other hand, is known for its amazing coverage, but its range for any single device is always tied to how close you are to the next cell tower.
Next up, and for the Internet of Things, this is absolutely massive, is power. If your sensor is stuck out in a field or buried in a wall, you can't just go out and change the battery every week. This is where LPWANs are the undisputed champions. No contest. They make it possible for devices to last 5, 10, sometimes even 15 years on one battery.
Then you've got data rate. This is simple. Are you trying to stream high-def video, or are you just sending one temperature reading every hour? A 5G connection is like a data fire hose, just a massive amount of information flowing constantly. A LoRaWAN connection? That's more like a slow, steady trickle. You have to match the size of the pipe to the data you're sending. And finally, there's spectrum. The easiest way to think about this is like radio highways. Licensed spectrum, which is what cellular uses, is like a private toll road. It's perfectly maintained, it's super fast, and it's incredibly reliable because operators pay for exclusive access. Unlicensed spectrum, which is what LoRaWAN uses, is more like a public city street. It's free, it's flexible, and it gets the job done, but you might run into some traffic or interference from other devices using that same road.
Now this slide right here is where it all clicks into place. Let's just walk through it. Take a look at the top row, LoRaWAN. You see that? The range is massive, over 15 kilometers, and the battery life is measured in years. But look at the data rate. It's tiny. Now let's jump all the way down to the bottom, to 5G. The data rate is gigantic, enabling things like ultra-reliable low-latency communication for robotics and AR. But look at the battery life. We're talking hours or days, not years. You see that pattern? As your data rate skyrockets, your battery life just plummets. This is the fundamental law of WWAN. You can have incredible speed, or you can have incredible longevity. You just can't have both in the same package. There's no single best technology. There's only the best technology for your specific project.
So to make this super practical, here's your checklist. Before you even think about picking a technology, you've got to be able to answer these 5 questions. 1. What data do you actually need to send? 2. What's your power source, battery or plugged in? 3. Is there coverage where you need it? 4. What's the total cost going to be? And 5. Super important, how are you going to keep it secure?
All right, that's enough of the theory. Let's see how these technologies are actually being used out in the real world. It's time to check out some winning plays.
Let's start with smart water or gas meters. They're usually stuck in basements where cell service is terrible. They have to run for more than a decade on a single battery, and they only need to send a tiny reading once a day. This is a tailor-made job for our low-power specialists, WWAN and NB-IoT.
Okay, now let's think about tracking a fleet of delivery trucks. Here, mobility is key, and you probably need more frequent updates on their location. This is where the cellular team, especially LTE-M or just standard 4G, really shines. They give you the coverage and data you need for assets that are always on the move.
Now picture the inside of a huge, modern factory or a shipping port. You've got autonomous vehicles, robots, all needing instantaneous command and control. Even a millisecond of delay could be a huge problem. This is the absolute killer app for private 5G, which delivers that ultra-reliable, near-zero latency performance they need. And for our last one, let's go all the way back to that sensor in a field. If you want to monitor soil moisture across hundreds, even thousands of acres, you need 2 things: incredible range and super long battery life. This is the home turf for LoRaWAN. It can cover these vast remote areas super efficiently and at a really low cost.
So we've seen how things work today. But what about tomorrow? What does the next season of wireless connectivity have in store for us?
Well, there are 3 big trends to watch. First, that explosive growth of private 5G in industrial places like factories and ports. It's really just getting started. Second, we're going to see more and more hybrid devices, smart gadgets that can use multiple technologies, maybe using LoRaWAN for a daily check-in, but then switching to 4G if it needs to upload a big chunk of data. And finally, the whole ecosystem is just getting more mature, which makes all of these technologies easier and more reliable to use.
And that brings us to the final and most crucial point. We're not just connecting computers to the internet anymore. We're connecting the very fabric of our physical world. The choice of wireless technology is now a foundational decision for building smarter cities, more efficient businesses, and more resilient infrastructure. So the real question isn't just which technology is the best, it's which connection will you choose to build the future.